you, everyone. Thank you to the society for inviting me to be here today. Not having any formal training here, I do, but I only have my son that is sitting over there, and he's following my step, wondering why it is wrong. He will be having also his speech tomorrow in one of the innovations in aquaculture. So you'll see what he's doing in his research, much better than I am doing. That's good. Well, I'm going to talk with fundamentals. What we are here, fundamentals in regarding our solid controls, whether it's going to be in a intensive flow through system or recirculation system or partial recirculation system. The only thing I would like to show here also is this network that we call it Serial Plus. We have a web page of that network. It's related with biointegration systems, so we biointegrate aquaculture with also with the baby. Aquaponics will be maybe the most knowing the thing that we may know the most, but also we are trying to do the same thing with saltwater and other things. We have a web page in there that is in Spanish. Hopefully that web page will be attached to the AAS web page as well. But if you go to that page, you will see also a lot of videos and stuff related with bilateral 10 countries related in there, all Latin countries plus Spain as well is involved in that Serial class. So you're welcome to visit that. The topic that I would like to go through today is we will talk about wastewater treatment, generation process, physical characteristics, size, physical characteristics, sedimentation, and finally with some general guidelines for device selection and sizing. And because we're talking about fundamentals, actually any of us will go to those books, including the yellow one, but this is a new version right now. I don't know what AAS stands for. Please go over there. 10% off for any members. Our membership is free right now here, so please grab what you book. All right, but you have a lot of books. I put those over there that is text and talk about fundamentals. The first one, the last one, is actually fundamentals in aquaculture engineering. But right now, if we move forward, this is some stuff about fundamentals. I did put a salmon in here. Chile is doing salmon, mainly salmon. It's very similar to the talk that we saw this morning, the first one, with another fish, of course. But as you can see here, in aquaculture, everything starts with feeding your animals. And when you feed your animals, all the trouble starts when you look into the engineering perspective. Because the biological of the fish or the animal you are doing will be doing some transformation of that feed. And one of those transformations is taking the feed and also do some digestion, but not all feed will be digested, so will be releasing feces, and not all the feed will be eaten, so will be some feed that will be left. And those will become particulate waste that when you are doing a flow-through system, maybe it's not a big deal in your tank. It will be a big deal in the environment. But if you start doing a partial recirculation, then they will be a big deal. Then we need to go to the mass balances and try to figure out which will be the concentration and the flow rate to keep a certain load of solids in your system. And if you do recirculation, it will be even worse if you don't take care of how to remove those. Besides, if you have some machines in your recirculation system, let's say UV system, those UV system could be not performing very well if your water is too dirty because of the presence of solids. Also, your piping, you have to design very well your piping so to not allow any solids settle in your piping. Every time we're saying how many solids settle in our fish tanks or in our settle devices, but I don't know how many of you have been seen in your piping. How many solids settle within your pipes? So, saying that, why do we want to remove solids at first? Hopefully, I will say we're able to put a cannula in the anus of each fish, but that's impossible to do. So we want to remove the solid because if they take too long in the water or in the system, they will go under several processes. One of those could be mineralization. And if you're not doing aquaponics, you don't want anything other nutrients accumulating in your system. If you do aquaponics, you want the mineralization going in there, but otherwise you don't want to do that. Because if they do mineralization, then you will have a lot of bacteria doing the work for that, and they will consume a lot of oxygen and also releasing more ammonia and become floccular and stuff like that. Also, something that Ed, and especially the last talk was talking about the tanks design, is how do you use the solids? Solids are they are not stones, they are very soft. So whatever waterfall you have or turbulence, they will break down those solids. As the solids break down, they will become very small, and they became very small, and more difficult will be for you to remove those solids from your system. So what do we know about the solids? Well, basically, we call them the total substance solid, and we have these differences between them. Something that we call the dissolved solids, all of those that are less than 1.2 microns. Then we call the other one that we call the suspended solids. Those are between the 1.2 micron and 100 microns, and they will take more than an hour to settle. And then we call the other one that are settleable suspended solids. That usually they are usually more than 100 microns, and they will roughly settle within an hour. So basically, that is the differentiation of the solid, and why the main thing that you don't want the solid becomes so small, because then it will be very difficult to remove them. So moving to the next topic about universal process, I want to let you know this skin drum filter is running to treat the effluent from an open flow system growing salmon in Chile. So what we would like to have is all this water, we don't want this water in our system. Actually, we would like to have water more or less right there, depending on the characteristic of the fish, or also depending on your system, what you're doing. So where all your system design will start with the tanks. So how you design your tanks, so the solid that are producing in your system, and then remove it from your device, and then when you remove it from your tank, they need to go through your piping. But also have to take care about how you do that, because your piping, if they don't have enough velocity, it could be like this, or it could be like this, or it could be like this. So sometimes we are not looking what happened in our piping. I'm not doing a talk about piping right now, so I'm going to leave the piping right there. But actually, we have some research that we've been doing about what velocity we need to do in the piping, with what range of numbers have to run to remove the solids, what happened with the solid within the piping, where they are traveling from the tank to the setting device, wherever you have that. In Chile right now, the largest tank that we have for attracting salmon in the recirculation system are about 1,200 cubic meters. That means about 15 meters diameter. So meaning that your radius will be roughly 8 meters. So that will be the timing for the solid to travel wherever they need to go for the treatment. Most of the time, you will have this kind of devices settled or attached close to your tank. A certain device that could be either a swim or either a radial system, or sometimes could be pumps, certain tanks. This one is also located in Chile for an open flow system growing Atlantic salmon. So they're also working for getting all the solids settled in there. The other device that is most common to see are the screen drum filters we use in RAS or in partial recirculation system, and also including open flow system when I'm removing or releasing the water to the system or to the environment. Much recently, we see in Chile, a few companies are now including also the foam fractionators to remove some solids. But in this talk today, I'm not going to say anything about foam fractionation. I will just focusing on certain devices and screen devices. But the history doesn't stop right there. When you have all these solids, you also need to work out on how you are going to dispose of solids. This talk is also not related with that, but something that we do in Chile with the water, the solids, or sometimes other technology, we dry the solids, and then you see over there, it looks like flour, actually. Right now, we're trying to figure out what other uses to have for those solids instead to dispose in any landfill. Most of the things right now are looking for some kind of agricultural application for those. So what about then our physical characterizations? First of all, when we do the design to